In this tutorial, we are going to learn about Kubernetes deployments. This is a continuation of my previous video. There, I explained about pods and demonstrated an example where we create a pod to serve a simple Python Flask API application. Now that we know about pods and why we need them in the first place, let's learn about Kubernetes deployments. Before talking about deployments, it is important to understand replicaSet, since deployment uses replicaSet behind the scene. A replicaSet's purpose is to maintain a stable set of replica pods running at any given time. It is often used to guarantee the availability of a specified number of identical pods. In my previous video, I created a simple pod using this definition. I also went over how to set up Minikube and explained why we need this image pool policy field to be set to never. The pod here is created for this image, and this is the Docker file that I used to create that image. And this is for a simple Hello World Python Flask API application. Use the pods template and create a replica set. So here the API version needs to be apps v1. The kind needs to be replica set, and the spec section is going to change. We have some new fields here that I'll go over. The replicas field is used to specify how many pods should run concurrently. The replica set will create or delete pods to match this number. If you do not specify spec.replicas, then the default is 1. The spec.selector is a label selector field. These are the labels used to identify potential pods to acquire. In our example, they should match this label. In the replica set, the spec.template.metadata labels field should match this field. If they do not, then Kubernetes won't create the replica set for us. Let's go ahead and apply this replica set file, and then let's go ahead and see the pods that it created. So as we can see, there are 3 pods running, matching the number that we specified here, and the label matches the label that we have here. To go over an interesting behavior with replica sets. If we try to create pods that match the same label as we identified on the replica set, the new pod will be acquired by the replica set. Let's say we have a template for a pod that has a label that matches the same replica set. Let's first see how many pods we have. So we have 3 pods created by the replica set. Now, if we were to try to apply this pod template and then see how many pods we have, this new pod that was created was acquired by the replica set, and at the end we only have 3 pods running. That is because the replica set acquired this new pod, but because the number of replicas was 3, it terminated this bare pod to match the number of the desired replicas that we specified in the template. So if I do get pods again, we only have 3 running. Now that we learned about replica sets and the purpose they serve, let's learn about deployments and why we need them. Deployment is an object which can own replica sets and update them and their pods via declarative server-side rolling updates. While replica sets can be used independently, today they are mainly used by deployments as a mechanism to orchestrate pod creation, deletion, and updates. When you use deployments, you don't have to worry about managing the replica sets. Deployments own and manage their replica sets. As such, it is recommended to use deployments when you want replica sets. I'm going to use the same definition of the pod, paste it here, and change the kind to be deployments. We then go ahead and apply. And then try to see the pods that were created using the deployment. Now you might wonder, what advantage does creating a deployment have over a replica set? Let's talk about that in detail. The application that I demoed deployment created 3 pods corresponding to the replicas field that we specified. Now, if we were to update our application, let's say add a new endpoint and deploy this new version, if deployment was to delete all the existing pods and bring out new ones, it would lead to downtime. And also, if there were issues or problems in the new version, we wouldn't be able to cache that without having downtime. Instead, it does this in a rolling fashion. Brings up a new pod using the new image, and after it ensures that it's healthy and it can serve traffic, terminates the existing pod and replaces that with a new pod. It repeats the same process until all the pods are on the new version, or we have all the previous pods terminated, and we have the desired number of replicas for the new version created. This allows us to achieve zero downtime, because if there are issues during the process, it will stop and our application is still up and running and serving on the old version. There are 2 important fields that I would like to go through, because this gives us more control over how the update should happen. The first one is called max unavailable. In this case, I set max unavailable to be 1. This means that the maximum number of pods that can be unavailable during the update process. So if we visit the update process again, it creates a new pod and terminates the old one. In this case, we need to have 2 pods running and be available at any given time, because replicas minus max unavailable will give us the maximum number of available pods that needs to be up and running. So in this case, if there are issues here, it would stop and not roll out the updates to the remaining pods and give us the maximum number of available pods that we specified here. The next configurable field is called max surge. Max surge specifies the maximum number of pods that can be created over the desired number of pods. If we visit the rollout process again, there is a brief period of time where we have 4 pods. There's a brief period of time that deployment scales up the number of pods, and in order to know how many pods will be created during the scaled up process, we need to add max surge plus replicas, and in this case is 4, and that's why we have 4 pods during the update process for a brief period of time. Now let's see this concept in action and try to update our deployment. First, I'm going to add the configurable fields that we talked about, and after that I'm going to update our image to a one that doesn't exist and has a problem. Here we have max unavailable set to 1 and max surge is also set to 1. We have 3 pods running, and if I were to apply this new change and also try to see the pods we have 2 pods running, That is because 3 minus max unavailable. That's the number of available pods we have. And then as you can see, it's scaled up to 4 pods, which is replicas plus max search. Thanks for watching this tutorial. If you did enjoy, please don't forget to like and subscribe, and stay tuned for future videos on Kubernetes concepts.